Hi everybody, myself Dr. R. Balamurugan, working as an associate professor in the Department of Electrical and Electronics Engineering, K.S.Rangasamy College of Technology. I am going to explain about the speed control of induction motors. Let's we explore the slides. Outline of my presentation include introduction, methods of speed control, advantages of speed control and its applications. So basically, induction motor is widely used in many applications of industries like conveyor belts, fans, compressors. So each and every application needs a particular speed control technique. So the basic commonly used techniques are constant control of stator voltage, control of supply frequency, variation of number of stator poles, modification of stator or rotor circuit resistance, and slip power recovery techniques. So all these speed control techniques will be classified under a common title as constant torque applications or variable torque applications. Based on the torque control, it will be classified as constant and variable torque. If the load torque remains unchanged over the speed range, it will be classified as a constant torque application. If the load torque is varied, the speed control will be termed as the variable torque application. So the choice of speed control also depends upon the performance requirements, energy efficiency, and economic factors of those particular application. So the methods of speed control classification. So basically, the speed control of the induction motor is classified as pole changing methods of control, stator voltage control, supply frequency control, rotor resistance control, and slip power recovery schemes for controlling the speed of the induction motor. So the pole changing method is further classified as multiple stator winding control, method of sequence poles control, pole amplitude modulation control. So let's we explore each and every speed control methods and its working. So first we will see the pole changing methods. It is a discrete speed control, but it is not a continuous control. It is used for the application of two or more speeds. Here we know the concept that speed is inversely proportional to the number of the poles. So by changing the number of the poles, the synchronous speed can be altered. Next, multiple stator windings. So it offers good efficiency, but cost and size of the motor will be increased. Into the commonly used application are machine tools and cranes, because here the stator winding with the different poles are provided in each motor. So based on energizing the stator windings, the desired speed can be obtained. And the method of consequent poles, the speed ratio is usually 2:1. It requires less copper compared to other methods of speed control techniques. And one pole sets acts as a consequent pole for the other. So number of the poles connected will be changed by reconnecting the stator windings. Next, pole amplitude modulation technique. Here, the stator MMF can be modified, and which in turn controls the speed. Achieving this can be obtained with the help of the winding connections, and it can be used for constant torque and variable torque applications. So the second main classification is stator voltage control. Here you can see the diagram which uses the thyristors for controlling the input voltage which is given to the three-phase induction motor. So the stator voltage is controlled by controlling the gate pulses which is given to the three phases, that is bidirectional thyristors. This application of stator control can be given to fan and pump load speed controls. Poor efficiency is obtained at low speeds due to increased losses, and reduction in voltage reduces torque, hence speed decreases. So this is a easier way of controlling the speed. Next one is supply frequency control. The input supply frequency can be varied by the help of the inverter. So this we generally call it as voltage bar frequency control, and it provides excellent frequency control where efficiency can be controlled excellently and torque can be also controlled. This most widely used in variable frequency drive applications. The last one is rotor resistance control. Here the slip rings are connected to a rotor circuit, which is connected in turn connected to the external resistance. By varying the resistance, the rotor speed can be controlled. It is not suitable for continuous operations. So the disadvantages in this rotor resistance control is it has significant losses in the external resistors. The last one is the slip energy recovery schemes. So here The slip ring induction motor, the wastage of slip power from the slip ring induction motor can be used to control the motor speed. Basic control schemes are static Kramer drive and static Serbius drive. It can be suitable for high power constant speed applications. But the main drawback for this scheme is it is complex and costly, but energy is efficient here. Next, advantages of speed control. Speed control offers several benefits by improving the performance and efficiency of the motors in various applications. So techniques like variable frequency drive, based frequency control reduce the power consumption, and rotor and slip power recovery schemes can be used for heavy starting loads. And pole changing and cascade control methods can provide a speed variation without complex electronic circuits. Speed control reduces mechanical stress and prevents overheating, extends a machine's life, and increase the flexibility of various applications with different operating conditions. Applications of speed control. Speed control of induction motors are widely used in many industries for getting precise control over the speed, and mainly used for pumps, fans, blowers, HVAC systems, where variable frequency drive based control helps energy saving and regulated flow. It can be applied for conveyor belts, mixers, packing machines, adjustable speed process controls. Rotor resistance control in particular can be used in cranes, hoists, elevators, and heavy duty machines to control the drives, which require high starting torque. Slip power recovery methods can be used in large industrial motors such as paper mills, cement plants, rolling mills, etc. Pole changing methods find applications in textile mills, fans, blowers, where fixed speed can be used. Cascade control method is particularly used in industrial systems needing multiple speed levels and smooth torque control. Thank you for giving this opportunity. Thank you.